So now we will begin on integration. And so the first thing we'll talk about of integration is it's basically the reverse process of differentiation. So say you have a function, you differentiate it, then if you integrate that result, then you just get the original function. So this is why it's sometimes called anti-differentiation. But because these two are the same thing, we just don't use the word anti-differentiation. So, if integration is the reverse of differentiation, then think about what the power rule will be for integration. So as we know, d dx of ax to the power of n is equal to an x to the power of n minus 1. So, therefore, the integral, and this is our integral symbol, of ax to the power of n will equal ax to the power of n plus 1 over n plus 1, right? Well, let's take the example x squared and x squared plus 9. d dx of that would just be 2x, and 9 differentiates to 0, right? And then so d dx of x squared is also 2x. So then if we just integrated this, following our rule here, we do 2x, and that becomes squared, over 2, we get x squared. Well, that doesn't give us x squared plus 9, does it? And that's why when we integrate something into an indefinite integral, we must always add a plus c to account for any constant that might have been differentiated to 0. Now, sometimes you may want to rewrite some of your things. So say you're trying to do the integral of x to the power of 4 minus 2x plus 5 over 2x cubed dx. Oh, I should have wrote dx. These are sort of kind of like your integral brackets. And when we do areas under a curve, we'll explain what the curly symbol and the dx actually mean. And here, I would instead rewrite this as I would split up the fraction and times that by x to the power of minus 3. And then I would expand that. And leave it as negative powers. And then I could integrate this normally. And then that would be my answer. Now we could, if you are given a point that the curve goes through, then you can evaluate what C is, because say it goes through the point 1, 8, then what you can do is you can say that, okay, 1 squared over 4 plus 1 over 1 minus 5 4 times 1 squared plus c will equal 8, right? So then that'll be quarter plus 1 minus 5 quarters plus c equals 8, and that's c equals 8, I think. Yeah. So therefore, and then from there, you could give the actual equation of the graph. So in summary, integration is the reverse process of differentiation, and we get this as our reverse power rule. When we see a curly thing and a dx, the thing inside that is the thing we want to integrate. And then when we have a more complicated thing, we want to integrate, and it's the same thing as when we might have to differentiate it. We just split it up and try to combine it into like one nice polynomial expression, not with fractions and stuff. And then we can, if we know a point that the curve goes through, we can use that information to evaluate what c is and then give the actual function. You could say that if you said this was dy dx, then you would say that this is y equals da 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 da. Conversely, if this was d squared y over dx squared, second derivative, this would instead be dy dx. And if you were ever going from d squared y to over dx squared and trying to eventually get to y again, remember that you need to find the plus c for the dy dx first and then integrate that, because then that constant will then have an x attached to it when you integrate it into y. So don't forget that.